Hello, my name is Yifei. For my final project, I implemented an end-to-end panoramic image stitching pipeline. The pipeline takes as input a sequence of images and blends them into a single panoramic image. Panoramic images offer a way to capture and explore wide field of view scenes. They are now a common feature of smartphone cameras and find applications in museum exhibits, tourism, and education. Within the domains of computer graphics and vision, the automated construction of panoramic images, also referred to as image mosaics or stitching, has been an extensive topic of research. Motivated by my interest in the mechanisms behind image mosaicing, this work implements and analyzes several prior techniques as part of an end-to-end panoramic image stitching pipeline. Image stitching generally comprises the following steps. First, given a set of input images, we must first determine the set of transformations to represent the relative spatial relationships. Then, using these transformations, we can warp the images into a combined panoramic image space. Lastly, we have to blend the images into our final panorama. To align images, I first followed the approach described by Brown et al. In their 2005 paper, which performs feature-based alignment. I first identified potential features using a Harris corner detector. I then applied non-max suppression to reduce the number of features. Afterwards, I matched features across images using Lowe's ratio test. Given these feature pairs, I solve for a homography to warp one image to another using a ransack algorithm. We do this instead of solving for the transformation directly, since the initial matches may contain a significant number of errors. With the alignment between images recovered, I finally applied a linear blending scheme where I combine the images as a weighted sum, with the sum associated with each pixel set to the distance between that pixel location and the center of the image. With the alignment and blending steps all implemented, we now have a functional panoramic image stitching pipeline. However, this initial implementation is just one fairly naive approach. Therefore, to improve upon this pipeline, I explored several alternatives. First, for the feature matching step, two commonly used approaches now are SIFT and ORP features. I therefore quickly prototyped these alternatives and compared the results with our initial implementation. Then, for the blending step, I implemented Brown and Lowe's multi-band blending approach. Effectively, instead of blending directly, we first construct a Laplacian pyramid for each image and perform blending at a level-by-level basis. One last extension I worked on was to implement Brown and Lowe's panorama recognition algorithm. Previously, images had to be inputted in a particular order. What panorama recognition effectively tries to do is to identify which images are good pairwise matches first. A graph can subsequently be constructed from these pairwise image matches, and panoramic sequences can be extracted as a connected component of this graph. Here is just a quick result from an experiment where I passed images from two different panoramas. The strategy is able to distinguish between the two and then return the sequences in order. In the following, I show several results from applying the pipeline I built to several online and personally captured images. As you can see, the results are pretty decent. To conclude, I wanted to mention a few directions for future work. First, besides the approaches I've implemented, there are plenty of other alternatives. For instance, for blending, one particularly interesting approach is to first identify the appropriate seams between images through graph cut optimization, then performing gradient domain fusion. Also, beyond simply improving the existing pipeline, it would also be interesting to explore enabling interactive editing, such as in the work by Agarwala et al.